Hi, I'm Anna Newman, and this is my second digital logic project where we made a 5 by 5 bit sign multiplier using the de0 board and Verilog. Alright, so we're going to be using the bottom switches. The left 5 will represent one number, and then the right 5 will represent another number, and the numbers are going to be in the 2's complement, so the rightmost switch for each number is going to be the least significant bit. So then we will multiply them together, and then the numbers will show up on the 7th segment display, which is above the switches, and they are going to appear in hex. Okay, so for this project, two numbers are given in the 2's complement. So the first thing I'm going to do is to check to see if either one of them or both of them are negative, which is shown by the farthest bit. If the farthest bit on the left is a 1, then it is negative, and then if it's a 0, it is positive. So if it is a negative, I'm going to take the 2's complement to make it positive, and then I will add them up together, and that is 3 on the strategy list. Add up multiplication products, which I'll explain later on, and then I will turn those numbers into hex, and then display it on my de0 board, and then make sure to print the correct sign also on the board. So this is the main module for my code. The first 9 lines I'm initializing everything, and then after that I'm checking to see if my x and y inputs are negative, and if so, I take the complement of them. And that's what xx and yy become. And then this is the end of the loop I was just showing, and then the loop or the if statement that starts on 32 is checking to see if the number will be positive or negative. So now that we made both of our numbers positive, we can do a multiplication now of two positive numbers. And that's what this representation is right here, with the m's being one number and the q's being another number. So this is how the multiplication works. Line 1 is q0 multiplied by m, and then line 2 is q1 multiplied by m, but it's shifted over 1 to the left, and then line 3 is q2 times m, but shifted twice over, and then basically keeps following that pattern, as you can see from my picture right here. I will refer to these lines in my code. Lines 1 through 5 are added together, which represents the product of m and q. P0 through P9 is a 10-bit positive number because we made the numbers positive earlier in the code, so that'd be easier to multiply them together. This is the code that does what I just showed you on paper. I created wires D0, D1, D2, D3, and D4, which will be 9 bits of just 1 or 9 bits of just 0. For example, line 45 assigns D0 to be 10 bits of all 1s if the least significant bit in XX is 1. If the least significant bit of XX is equal to 0, then D0 will be equal to 10 bits of zeros. This is all to set up the next line, line 46. Line 46 is the multiplication of the least significant bit in XX multiplied by all of y. This is done by ANDing yy with D0. If D0 is equal to all 1s, it's as if I'm multiplying by 1, because yy ANDed with 1s is equal to yy. And if D0 is equal to zeros, then the answer is going to be zeros, which is exactly the same as being multiplying by 0. So this is like the same picture as I showed before, and I called it line 1, line 2, and line 3 in my code. So you can see that Q0 would be like the least significant bit, and I multiplied it by all the m's. So if Q0 was 0, then that whole line would be zeros, and if Q0 was 1, then that whole line would be m's. So here are all the lines in Verilog. I want you to notice all of the shifts I do. So line 2, I shifted over 1, and line 3, I shifted over 2 to the left. And so that's when I add them all up, they will all add correctly together. So now I'm going to take all those lines and add them together in a 10-bit adder. So this is the 10-bit adder. I got it from the book. I always make the carry in 0, and then the carry out, I just have a place to put it. And then X and Y would be line 1 and line 2 if I was adding those two together, and S would be the sum of those two. So here, pattern is what I'm passing all of the lines into. So this is how I'm adding up all the lines. So for pattern BOCO, I add line 1 and line 2 together, and then the sum is S1. And then the next line, pattern BOC, I just took off a 0 because why not? I add line 3 and S1, and that has a sum of S2. And I keep doing that until the very end where I add line 5, and that would be the sum would be S4, and that is the product of the two positive numbers. I have now multiplied the two numbers. I will be putting them in hexadecimal on the 7-segment display. Display, the green word to the very right, which is from P0 to P3, is the output for the rightmost 7-segment display, and it can do anything from 0 to F, where F stands for 15. And then display 1 would be the output next to the 7-segment display next to it, and then display 2 would be the third one, and then the fourth one would be the sign, which was already determined from the beginning of the code. So this is the module decoder, which I call in my other module multiplier. This basically is just outputting everything on the 7-segment display. The case for a neg basically just says if there's going to be a negative sign there or not, and that's determined earlier, so we don't have to worry about that when multiplying. So x, this is a different x than it was in the last module. This x is the product of the two inputs. So here there are 3 cases. So there's case from the first 3 bits, so first 4 bits, sorry, my bad, from 0 to 3, and then the next case is the next 4 bits from 4 to 7, and then the last case is not 9 and 8. And so basically we can just add those numbers up and print them on the screen, and it will show them in hex.